Hello students, today we are going to discuss some questions from the chapter Solid State Unit 1. Now first question is, how many atoms constitute one unit cell of a face-centered cubic crystal? So in face-centered cubic crystal, the unit cell is your face-centered, right? Now what is face-centered unit cell? In this unit cell, the atoms will lie at the corners, right? All 8 corners, and at the same time it will lies at the center of all faces. So how many faces are there? 6. Now we know that the atoms which lie at the corner, right, it contribute how much to a unit cell? 1 by 8, because it will be shared by 8 unit cell, and the atom which lies at the face center, okay, it will contribute half to a unit cell, because the atom present here will be shared by 2 unit cell. So what would be the total number of atoms, okay, per unit cell in face-centered cubic crystal? So atoms are at corners, right, and it can contribute 1 by 8 to a unit cell. So how many are there? 8. Okay, plus atoms are at the face centered and they contribute half to a unit cell. And how many faces are there? 6. So your answer is 4. Number of atoms per unit cell of a face centered cubic crystal is 4. Now next is, what is the formula of a compound in which element Y forms cbse lattice and atom of X occupy 2/3 of octahedral void? Now in cbse arrangement, okay, so in cbse arrangement, the number of particle will, if your number of particle is n, then the total number of octahedral void will be n, and the tetrahedral void will be 2n, that we have already discussed. So, okay, so which one is forming your cbse? So Y forms cbse, right? So त्यसले गर्दा के हुन्छ तिम्रो? So let us assume. So let the number of Y atoms, so let this be n or x, anything, okay. Then what would be the number? Since here we have to consider only octahedral void, right? So if the number of atom in cbse arrangement is n, then your number of octahedral void, okay, it will be also equal to n. So now your X occupies, right? So X occupy 2/3 of octahedral void. So which means your X occupied 2 by 3 into n. Okay, so this is the number of your position occupied by X. So what would be the number of X then? So therefore, number of X atom. भयो, यसले जति पोजिसन अक्युपाई गर्यो भन्नुको मतलब त्यतिवटा के छ? X atom छ. So कति अक्युपाई गरेको छ? 2 by 3 n. Okay. Now, so what is the ratio of your X atom, Y atom per unit cell? So number of X atom per unit cell is to number of Y atoms. Okay. कति हुन्छ? So X को कति छ? It is your 2 by 3 n is to Y को कति छ? n. So n will get cancelled. You will get 2 is to 3. So therefore formula हुन्छ तिम्रो compound को, it is your X कतिवटा छ? 2 and Y 3 per unit cell. So this is the formula for the compound for this question. Question number 2. Answer के हो? X2 Y 3. Okay. Now next question is, calculate the number of unit cell in 8.1 gram of aluminium. Okay. If it crystallizes in a face-centered cubic structure. So you are asked to calculate the number of unit cell in 8.1 gram of aluminium, and the unit cell is your face centered. Okay. Now, okay, so what is the given mass? Given mass is how much? It is 8.1 gram, right? And molecular mass or atomic mass of aluminium is your 27 gram per mole, right? Now, what is your number of mole? So, which is N. N is what? Your given mass divided by molar mass. So, it is your 8.1 divided by 27, which is equal to 0.3 mole. Okay, sir? Now, okay, we know that, right? So, 1 mole of anything, your aluminium, anything, 1 mole of aluminium is equal to 6.023 into 10 to the power 23 aluminium atoms, right? Okay, na? Manepachi hamro kati mole cha? 0.3 mole of aluminium. भन्नुको मतलब कति छ यहाँ? 0.1 mole मा 6.023 छ भनेपछि 0.3 मा you need to multiply, हैन? 23 into 10 to the power 23 number of your aluminium atoms. So कति हुन्छ multiply गर्दा? 9, 7, 0, 18. So 1, 2, 3 and 4. 1, 2, 3, 4. यहाँ छ into 10 to the power 23 तिम्रो aluminium atoms हुन्छ. Okay, कहाँ? कतिमा? In 0.3 mole of aluminium. So here you need to find the number of unit cell, not the number of atom. Okay. Now in FCC, face centered cubic structure. Okay. Number of atoms per unit cell. कति हुन्छ भने FCC मा number of atom per unit cell it is 4. Therefore, number of unit cell in this mole कति हुन्छ? Will be equal to तिम्रो total 80 number छ भयो, each unit cell मा 4 छ भनेपछि हाम्रो total unit cell आउँछ total number, okay, divided by 4. So कति आउँछ? If you divide it by 4, so 4.5, okay, 19 into 10 to the power 22. So this is the answer. So number of atoms or number of unit cell in 8.1 gram of aluminium or 0.3 mole of aluminium is equal to 4.519 into 10 to the power 22. Very so your this mass is given, right? Atomic number is mass is given. So ke garnu parcha, from this given mass and atomic mass you easily will get the number of mole. And number 1 mole ma kati huncha? 6.023. So 0.3 mole ma huncha, you have to multiply, right? After multiplying you will get 1.8079 into 10 to the power 23. So face centered ma हामीलाई के याद छ? So number of atom per unit cell कति हो? 4 हो भयो. हाम्रोमा 80 number of atoms छ. If you divide it by 4, you will simply get the total number of unit cell present in 8.1 gram or okay 0.3 mole of aluminium. Now what is the next question? बुझ्यो? So answer यहाँ कति छ? For this answer is 4.519 into 10 to the power 22. Okay. Now next question. 5. Okay, it's an alloy of gold and cadmium crystallizes with a cubic structure in which, okay, gold atom occupy the corner. So gold atom leke occupy garcha corners, okay, the cadmium atom fit into the face centers. Now assign formula for this alloy. So यहाँ पनि तिमीलाई formula चाहिएको छ. So formula को लागि you need to find the number of atoms per unit cell. अब यहाँ के भन्दैछ solution of your 5. So alloy gold ले के occupy गर्दैछ. Gold atom occupies corner. Okay, gold atoms occupy corners. भनेपछि number of gold atoms, okay, per unit cell कति हुन्छ? So corners मा छ. So corners मा atom ले कति contribute गर्छ भनेको छु मैले 1/8. Okay, र how many corners are there? 8 वटा. So कति हुन्छ तिम्रो into 8 गर्नु पर्यो. So total number of atom per unit cell कति आउँदैछ तिम्रो 1. ठिकै छ? त्यसरी नै cadmium. So के भन्दैछ? Cadmium atom fits where in face center. So occupy face centers all. भयो भन्नुको मतलब number of cadmium atoms, okay, per unit cell कति हुन्छ? मैले भने face center मा छ भने it will contribute half. भयो र कतिवटा face centered हुन्छ? 6. Okay, so total number of atom in face center कति हुन्छ? 3. So now ratio. So number of gold atoms is to number of cadmium atoms. So kati huncha? It is how much kati cha? 1:3. So formula ke huncha? Formula is your AU kati wata cha? 1, no need to write, and cadmium kati wata cha? 3. Now next is your 6, okay? An element with density is given 2.8 gram centimeter inverse cubes form a face-centered unit cell with H length 4 into 10 to the power 8 centimeter. Calculate the molar mass of element. So now note down whatever data are given in the question. So case Markoma, what is given? First measure density. So it is your 2.8 gram centimeter inverse cube. Okay. Now it forms FCC. So Z is there, right? What is the formula of density? It is equal to Z into M divided by A cube into Na, where Z is number of atom per unit cell, M is molar mass, A H length, Na Avogadro number. So Z, since it is forming your, it forms your FCC unit cell, so Z is how much? 4. Okay, sir. Now H length dekho cha 4 into 10 to the power minus 8 centimeter. Okay. Now we know Avogadro number, right? So this is equal to 0.0623 into 10 to the power 23. Bhayo. So ke nikalnu bandaicha timarlai? You need to calculate, right, molar mass. Now using equation, here's the equation. So rho equal to Z into M divided by A cube into Na. Okay, so Z is, so hamila chaheko cha M. So every time whatever is required, try to keep them in left hand side. So M huncha timro kati cha rho into A cube into Na divided by Z. Okay, rho kati cha? It's 2.8 into A is 4 into 10 to the power minus 8 centimeter cube. Okay, into Na 6.023 into 10 to the power 23 divided by 4. Okay, sir? Calculation garo jasari sajilo parcha yo 4 ma euta 4 काटिदिन्छु र यो दुईटा, right? 16 हुन्छ यहाँ. So 16 you multiply गर्नु. 269.83, okay, into 10 to the power कति रहेछ 24 र 23 गर्दाखेरि minus Okay, so minus 24 into 10 to the power 23. Okay, so 26 9.83 into 10 to the power kati huncha minus 1, or you can write this as 26.983 into and what is the unit? It is your gram per mole. Okay, so whenever you write down the answer, try to highlight it, and if it is a numerical one, okay, so make sure you are writing down the units, otherwise marks will get deducted. So every time while answering the numerical one, try to mention the units. It's very important. Okay, so this is how you do. So first you need to know the formula. र whatever questions मा के दिएको छ त्यो तिमीले लेख्नु पर्यो भयो, and you will get the easily after substituting it in equation भयो तिमीले के पाइहाल्छ, आन्सर पाइहाल्छ. So numericals is not that hard. Now next question छ तिम्रो 7. So what is the question? Silver crystallizes in face-centered cubic unit cell. Okay, if the radius of silver atom, so what is given? Radius. So radius is 145 picometer. Okay, and you are asked to calculate the length of side. Now see, so there is a relationship between R and A for all the type of unit cell, face centered, body centered, simple unit cell. So you need that relationship. Okay, तिमीलाई त्यो relationship याद हुनु पर्यो. Now यता के छ? Face centered छ. So AG crystallizes, okay, in face centered unit cell. So त्यसले गर्दाखेरि now what is the relationship for face centered between A and R? So 4R equal to root 2 of A. ठिकै छ, तिमीलाई चाहिएको छ A. Now R कति हुन्छ? root 2 by 4A. यता पिकोमिटर छ, सेन्टिमिटर, no need to convert. तिम्रो पिकोमिटर मिटरमा राख. ओके, जबसम्म तिम्रो कन्भर्जन को रिक्वायरमेन्ट छैन नगर्नु, वेस्टेज अफ टाइम. सो कति भयो? root 2 is here 1.414, right, divided by 4 into 145. 25, okay, and what would be the unit? So again this is your radius, right? So length hayo, so it is in picometer. So radius of your silver, it is your 551.25 picometer. Okay, now last two questions are account for the following. So first is Schottky defect, okay, lowers the density of related solid. So you need to give the reason. So Q. So what is Schottky defect? So first you should know that, right? So Schottky defect, what happen is equal number of cation and anion will be missing from its lattice side, right? So suppose so 12, 16 in volume. So plus minus, plus minus, minus, plus minus, plus, plus minus, plus minus, minus, plus minus, plus. Now Schottky defect ma ke huncha bhandakheri, okay, now equal number of cation anion will be missing from its side. Jastै यहाँबाट एउटा हरायो, anion दुईटा तीनटा. Okay, now in order to maintain electrical neutrality, same number of cation will be missing, right? कतिवटा गयो? तीनटा. So 1 2 3 भयो. So पहिला कति थियो number of atom? 1 2 ions 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, right? अब कति छ अहिले? So 1 2 3 4 5 6 7 8 9 10. So कति रहेछ? 10, right? So what happened? The number of atoms now it is decreasing, right? Because of the Schottky defect. Now what is density? It is mass by volume. So mass तिम्रो mass कसले गर्दा हुन्छ? So ions or constituent particle ले गर्दा हुन्छ. So तिम्रो number घट्दैछ. So what will happen? Mass घट्छ, right? Mass घट्नुको मतलब what will decrease? Schottky defect. The reason is in Schottky defect, same number of cations and anion will be missing from its lattice side. So the number of ion will be lesser, right? So for that reason the density will also decrease. Now next question or last question sir, conductivity of silicon increases on doping it with phosphorus. You could say type of this is your semiconductor, right? This is your N-type semiconductor. Why? Because silicon belong to group 14 and phosphorus it belong to group 15. Right? जब तिम्रो impurity higher valency को हुन्छ, so this is your N-type semiconductor. Now question is why the conductivity increases? So के हुन्छ तिम्रो डोप गर्दा what will happen? If तिम्रो silicon मात्रै भा, this is how your silicon will be linked, right, with the neighboring silicon atom. Now after doping what happen is some of the positions, okay, of silicon will get replaced by phosphorus. Now phosphorus use its, so it belong to 5 valence electron 4, हैन. So phosphorus use its 4 हैन valence electron out of 5. 5 वटामा 4टा use गर्छ in order to form covalent bond with the neighboring silicon atom. भयो 5 वटामा 4टा use गर्यो भनेपछि एउटा के छ फ्री छ. So each ले एउटा एउटा इलेक्ट्रोन दिन्छ हैन. So त्यसले गर्दा now this electron it is free to move, right? So free to move means now the conductivity will increase, okay? So तिम्रो conductivity के हुन्छ increase हुन्छ because of the presence of the fifth free electron. So this is all for today, okay? So thank you all, see you in next video. Thank you.